Okay, so let's discuss a concept which is called recursion. So what is recursion, right? So recursion is a function, and how it is different from the regular function. So in recursion is a function which calls itself basically, right? So here that's how we define recursion. So a recursion function is a function that calls itself, right? So here when we do recursion, right? So recursion sometimes basically allows us to write like compact code, like simple code. But in what situation we will use basically recursion, right? So here we will use recursion when we know that a large problem can be broken down into smaller problems which are exactly similar to the large problem, right? So for example, let's say when we compute a factorial for a number, right? Let's say that factorial we want to compute for 5. So factorial 5 is basically 5 times 4 times 3 times 2 times 1, right? So that's the factorial, right? But if you look at that, if you check that factorial of 4, it is 4 times 3 times 2 times 1, right? Okay. So now if you look at this 4 times 3 times 2 times 1, so it is factorial of 4. So 5 factorial we can also write in terms of 5 times 4 factorial, right? Okay. So you see that here, this factorial of 5, we can also write in terms of the multiplication of 5 and factorial of 4, right? So you see that here, what we are going to compute, we are going to compute factorial of 5, which we can compute using the factorial of 4 multiplied with 5, right? So such kind of problems where you can basically break down the problem into the similar problem, right? So the problem will be large. You will break down into a smaller problem, but that smaller problem will be exactly similar to the large problem, right? So in those situations, we can use recursion, right? So here, let's say you define a function for factorial. So let's say it's a factorial. You pass 5 there. And then here you can write that 5 times factorial of 4, right? So here you see that the function you call, the name of the function is factorial, and inside the function you call the same factorial function, right? So now the question is that when a recursive function calls itself, right? So it will continuously call itself, right? So how do we stop that, right? So in a recursion function, when you write that, there must be a base case or simplest case for which you know that the function will not call itself. It will give you a value or it will return something, and it will not call basically the recursion function. So that is the base case which we consider as a stopping case, because at that time the function will not call itself, right? And if we do not have the base case, then the function will split into two parts. One part where it knows how to compute, and other part it will call itself basically, right? So here in this case, let's say when you have this factorial 5, right? So what will happen basically, so when you define a function factorial, right? So let's say you call this function with 5 factorial 5, right? Okay. So then this is not a base case. So what the function will do basically, it will call this thing 5 times factorial of 4, right? Okay. So it breaks that in a smaller problem where you are calling factorial 4 and you multiply it with 5, right? Then when it will see 4 factorial, again it will call itself with, now here it will call like this 4 times 3 factorial, okay? And then when it sees 3 factorial, so it will call this thing 3 times 2 factorial, right? And then when it will see 2 factorial, so it will call 2 times basically 1 factorial, right? And we know that the factorial of 1 is 1, right? So here, this is our base case where we know that what could be the solution for the simplest case. So we know that factorial of 1 is 1. So now what will happen? So for this case, when the factorial function is passed with 1 factorial, so 1 will be returned, right? Okay, so this 1 now is multiplied with 2. So you will have, for this one, you will have a value of 2, right? So 2 basically will replace this 2 factorial. So now you will have a value of 2 here. So 3 times 2, 6. So 6 will be returned, and this return value will replace this basically 3 factorial. So now you will have 6 here. And then 4 times 6 is 24. So 24 will be returned here. 4 factorial will be replaced by 24. And then you have 24 times 5, which is 120, right? So that's how basically recursion function works, right? So here in recursion function, what you need to know that you should be able to break a large problem into similar smaller problems. So that one thing you should know that, right? So in case of factorial, we can do that. There are many problems where you can do that. For example, you can do Fibonacci sequence, you can do power function you can write in this way, right? And you can compute permutation, you can compute GCD. There are many problems where you can basically use this approach, right? So first, you should be able to break down the large problem into smaller problems which are similar. Then you should also know the base case where your function should stop, right? It should not call itself, right? So at that point, it should not call itself. It should return you a value, or it should not do basically. It should not call itself, right? So you should know a base case where you will stop calling that function, and for other cases, you will call the function itself, but you will also basically reduce the problem into a smaller set. Okay. So now let's see recursion through an example. So here we will use the same example for recursion, right? So we will use the same example for recursion that we discussed, factorial, right? So here we have two approaches, right? For factorial, one is through iteration, right? So we are not going to use the iterative approach. We are going to use the recursion approach, right? So here, to compute the factorial, right? So we define the factorial function, and let's say the factorial of given number would be large. So we declare the return type as unsigned long, and then this will take a number in num. And here what you will do basically, you will check the number. So let's define the base case. So if we can do this, if num less than or equal to 1, so then we can do this, return 1, okay? Else, what we will do basically, we will do num times factorial num minus 1, and we will return this value, okay? So here you see that the name of the function is factorial, okay? So name of the function is factorial. And inside the function, we are calling the same function factorial, right? So this implementation of factorial is a recursive implementation. Why? Because the function is calling itself, right? So that's called basically recursion function, right? Why it is recursion? Because this function is calling itself here, right? Okay. So here, this thing that you are seeing, that is called a base case, right? So here you have to know what is the base case for your problem, right? And here in the base case, you see that if the base case is made, we are not calling the function itself, we are just returning 1, right? In other cases, what we are doing basically, we are breaking the problem into two parts. One part is the num, and the second part, which is where we are calling basically the factorial function itself, right? So this is called recursive implementation of factorial function. And how we can use it? We can use it and declare a variable unsigned long, let's say result, and then we can, let's say result is factorial 5, right? And then we can print that. Okay, so now if we call this function, so let's see whether we are getting the correct result or not. we are getting correct result, right? So how does this function work, right? Okay. So let's start from here. So first time we call factorial 5. Okay, good. So we are calling factorial with parameter 5, right? So this 5 that you are seeing here, it will be basically copied into this num, right? So num will have a value of 5. And then you have this if else condition, 5 less than 1, which is basically false, right? Because 5 is greater than 1. So then we will have this thing, okay? So here, then we are calling 5 times factorial 5 minus 1, which is 4. So now what we will have we are calling factorial function again, right? So now the value of 4 will be copied to this num. And then we have if else condition. So 4 less than 1, false. Then we are again here. And there we are basically calling 4 num is 4 times factorial 3. Okay. So here now factorial 3 will be called. So 3 will be copied to num. So 3 less than 1 false. Then we are again calling this. Okay. Then we have 3 times factorial 2, right? And then, so again, we'll call factorial 2. So num will be now 2. So 2 less than 1, which is false. Then we are doing this. So we are calling this 2 times factorial 1. Okay. And then we are calling again factorial function with 1. So now num is 1. 1 less than 1, false, right? So then we are calling 1 times factorial 0, right? So now here factorial, you're calling with basically num is now 0, 0 less than 1, which is true. So this return 1. Now here, so factorial 0 will return 1, right? So now we have 1 times 1, we will have 1 basically, right? So this 1 will replace this fact 1. So now we will have 1 for that. So 2 times 1 will be basically 2. So this 2 will replace this factorial. So which will be 2 now. And then we will have 3 times 2, 6. So 6 will replace this factorial 3. We'll have 6 in place of that. So 6 times 4, 24. And then this 24 will replace factorial 4. So you will have 24 times 5, which is basically 120. And that 120 will be assigned to result, right? Okay. So your result will be 120, right? So that you are saying. So that's how basically recursion works, right? So in recursion, you should be able to break down the problem into smaller, similar problems, and you should know the base case where the function will not call itself. So in recursion, a function call itself in most of the cases, and there is one case where the function does not call itself. That's called base case. So you should know that where is the base case for your implementation for your recursive function, and for rest of the cases, you will call the function itself with some other basically stuff, right? So that's how we write recursive function. All right.